Welcome back, system design enthusiasts. Data is the backbone of any system, and understanding how to manage and store it effectively is super crucial. So let's dive in and explore all these data related buzzwords. First, we look at the relational or the SQL database. Then, we'll understand the non relational or the NoSQL database. Then, we'll understand how we can choose between a SQL and a NoSQL database. We'll look at the object storage. Then, we'll understand database sharding and database replication. After that, we look at caching. Eventually, we look at CDNs. Hearty welcome to all the design enthusiasts. In this lesson, we'll understand SQL or relational databases. Have you ever worked with tables or spreadsheets? If so, you already have a good idea of how the relational databases work. This is the closest analogy I can give for a relational database. Relational or SQL databases store the data in a table-like format. You can think of it like spreadsheets, having rows and columns. Relational databases are perfect for such type of data. What data? The data that has a well-structured format that can easily fit into the rows and columns. For example, think about the user data. It's structured. Why? Because it can be organized into predefined fields like name, email, phone number, and address. Some popular examples of relational database are MySQL and PostgreSQL. Now, when I try to think of relational database, I think of it as a well-organized library. In a library, each book is categorized and placed in a specific location based on its author, title, publisher, and cost. Now, contrast it with an example of unstructured data. You can imagine your storage room filled with all sorts of random items or junk items. It may be your own box of documents, photos, videos, chairs, tables, etc. There is no inherent structure to the stuff you are putting it there. It's all random. Welcome back, everyone. In our last lesson, we talked about a relational database and how they work well with the structured data, like neatly organized books in a library. But what happens when our data doesn't fit neatly into predefined categories or it is unstructured? Let's take social media posts as an example. Imagine trying to store these posts in a table with columns for text, images, and videos. Now, if the post has only text, the image and the video columns remain empty. Similarly, if the post has a video, the text and the images columns remain empty. This leads to a lot of wasted space in our table, which isn't very efficient. Take a look at this image. Here you can see how the table has many empty entries because each post doesn't always have content in every column. This is where inefficiency is coming in. The table is designed for a structured data, but social media posts don't always follow a strict structure. They're more like random items in our storeroom example from earlier, no predefined format. This is where we have the NoSQL database, which is ideal for handling this kind of unstructured data. So instead of forcing everything into a rigid table, NoSQL databases allow you to store each post just as it is. Each post can be stored in a flexible format, like a JSON document, which can handle different types of data: text, images, text and images, text and videos, anything. Let's take a look at the second diagram. Here, you can see how each social media post is stored as a JSON document in a NoSQL database. Each post is complete within its own document, and there is no wasted space. Plus, these documents can be easily accessed using a key like a post ID, for instance, making it quick and efficient to retrieve the data you need. Cool fact: NoSQL databases aren't just one type. There are various kinds, each designed to handle different types of unstructured data. We have key value stores, document databases like the one we looked, graph databases for storing relationships, white column databases, and even time series databases for tracking the data over time. Some popular examples of NoSQL databases include MongoDB, Cassandra, DynamoDB. These databases are designed to be highly scalable and flexible, perfect for modern applications that deal with a variety of data types. Might be unstructured, might be structured, whatever. So just like how a storeroom can handle all sorts of different items without any strict organization, NoSQL databases are perfect for handling unstructured and varied data. They give us the flexibility to store and manage data in a way
that fits our needs without wasting space or forcing everything into a rigid structure. Stay tuned for the next one. Welcome back, design enthusiasts. Now that we have explored both the SQL and the NoSQL databases, the natural question is, how do you choose between them? So let's dive into some general guidelines that can help you to decide. But keep in mind, it's not always black and white. Your choice will often depend on the specific needs of your project. First, speed. If you need very fast data access, NoSQL databases might be generally preferred over SQL. NoSQL databases are designed to handle large volumes of data and can retrieve the information pretty quickly, making them a great choice for real-time applications. Next is scale. When the scale is too large, NoSQL databases tend to perform better than the SQL databases. NoSQL databases are built to scale horizontally, meaning that you can add more database servers to handle more data. This makes them ideal for applications with massive amounts of data, like social media platforms or big data applications. But what if your data fits into a fixed structure? This should prompt us to think about SQL databases. If your data is well organized and has a consistent predefined format, like the user data which we saw, fields for name, email, phone number, address, etc. This kind of data goes very well with the SQL databases. On the other hand, if your data doesn't fit into a fixed structure, NoSQL should be your choice. Remember our earlier example of social media posts? That kind of unstructured data would go well with the NoSQL databases. Another consideration is the complexity of your queries. If you have complex queries that needs to be executed on your data, SQL is the better choice. SQL databases are designed for intricate queries that involve multiple tables, complex joins, and filtering. But if your queries are simpler and more straightforward, NoSQL databases can handle them just fine. They are optimized for quick, easy access to the data, without the need for complex querying or operations. Lastly, let's talk about flexibility. If your data changes frequently or is likely to evolve over time, go for a NoSQL database. NoSQL databases support a flexible structure, allowing you to add new fields, change the format of your data without much hassle. This is particularly useful for rapidly evolving applications where the data model isn't set in stone. So in summary, SQL databases great for structured data, complex queries, and applications where you can expect the data to be in consistent format. NoSQL databases, on the other hand, are perfect for unstructured data, large-scale applications, and scenarios where flexibility and speed are the key. You got it right. Flexibility and adaptability can take you much further than rigidity. After all, in both databases and life, the ability to evolve with the times can be the key to success. Remember, these are just general guidelines, and the best choice often depends on the unique requirements of your project. It's all about finding the right tool for your job. Stay tuned for the next one. Welcome back, everyone. The internet is full of photos, videos, music, and all kinds of files. But have you ever wondered where all this stuff is stored? That's where the object storage comes. Object storage is perfect for handling large amounts of data, like these photos, videos, audios that we constantly upload and share. In object storage, we simply store the data as objects. Imagine it like a big digital bucket where you can toss in all sorts of these objects: photos, videos, music, documents, etc. Some popular services that offer object storage are Amazon S3, Google Cloud Storage, and Microsoft Azure Blob Storage. Here's a fun fact. Amazon S3, one of the most popular object storage services, is currently storing over 100 trillion objects. So no matter how much digital stuff you have, there is plenty of room in the bucket. Stay tuned for the next one. Welcome back, all the amazing design enthusiasts. Today we are diving into something that makes our website load blazingly fast, no matter where you are in the world. It's called as the CDN, or the Content Delivery Network. I'll start with an example. Let's say Sweet Cody has all its servers in the US, and then a user from India tries to open sweetcody.com. The website assets like images, videos are pretty bulky, and this bulky content has to travel all the way from the US to India. Now, this long journey increases the latency, meaning the user has to wait longer for the website to load. This is where a CDN comes in. A CDN stores copies of your website's static content. What is a static content? The content which is static, aka that doesn't change too often. Things like images, videos, and other files. So a CDN stores copies of such static content at various locations around the world. So when someone from India, let's say, tries to access sweetcorey.com, they get the content from a nearby CDN server instead of waiting for it to come all the way from the US. Take a look at the diagram. You can see how users in India and the US get the website content from their nearest CDN servers. The users in India are getting it from the CDN in India. Similarly, the users in US are getting it from the CDN in US. This cuts down the distance the data has to travel and therefore speeds up the whole process. Stay tuned for the next one. Welcome back, design enthusiasts. In this lesson, we are going to talk about how we can make accessing the data faster by using something called as the cache. Accessing the data directly from the database can take some time. But if we want to speed things up, we use a cache. Think of the cache as a special kind of super fast memory where we store the frequently accessed data. In fact, accessing the data from a cache is around 50 to 100 times faster than accessing it from the database. It's like keeping snacks close to you at your desk while you study. So instead of walking to the kitchen every time you're hungry, which is like going to the database, you simply grab a snack from your desk. Again, similar to using a cache. But just like how you cannot store everything on your desk, a cache has a limited capacity compared to a database. That is why we store only the most frequently used data in the cache. Now let's look at what happens when you try to get the data from a cache. Let's look at the first diagram. Here, user 1 is requesting some data. The system first checks the cache. Since user 1's data is already in the cache, it is quickly fetched from there. This is called a cache hit because the data was found in the cache, so we have hit the cache. But what happens if the data is not in the cache? Let's look at the next diagram. In this case, user 4 is requesting for the data. User 4's data is not in the cache this time. So the system has to go all the way to the database to fetch it, which takes longer. This is called a cache miss. It's a miss because we cannot find the data in the cache and we had to go to the database to retrieve it. And by the way, after the data is retrieved, it is added to the cache so that the next time user 4 needs it, it can be quickly fetched from there. Now in the final diagram, user 4 requests the data again. Now this time, since we have already saved user 4's data in the cache, we just grab the data from the cache quicker and much faster. Just like grabbing the snacks from your desk. Using a cache is a great way to make your system faster by reducing the number of times you have to go to the database for the same data. You can use the cache at multiple layers. You can use it at the database layer, perhaps at the server layer, perhaps even at the client layer.